Today we are talking Hardy-Weinberg equilibrium. Now, the beginning, part one, is why? What the heck is Hardy-Weinberg equilibrium? Let's back up and ask, what is the problem that Hardy and Weinberg, independently in different places, were trying to solve? They both came up with the same solution, which means the solution cannot be that difficult, and it probably is a good one. So what were they trying to solve? And I'm going to go back here with my yellow highlighter. And the idea is that this is a tool to predict the proportions in a population, that is the percentage of homozygous dominant, heterozygotes, and homozygous recessives in a population. And it's not written here, but I mean when nothing's going on, when there's no selection, there's nobody messing with the organisms, culling some colors and keeping others. It pretty much looks like this. The problem that we face is if you have a group of animals or organisms, plants works too, and we're going to take a look at this circle here on the left, and say you have a group of black sheep and white sheep. The fundamental problem is that if we know that black is dominant and white is little a, then we know that the black sheep actually have some combination of heterozygotes and homozygotes in that group. What we don't know is how many. So we could take a guess, but we don't really know. We could say, oh, maybe there's half or there's a quarter. You look at the white sheep here, and we know these guys are all AA. So that's easy, right? They all show their genotype. But these guys over here, they don't show their genotype. They both have the big A phenotype here. So the question becomes, how do we figure out how many of them are heterozygotes? So the real answer looks like this circle on the right over here, where the white sheep, they are little a, but we're going to look at the other side, and we're going to see some of them are big A, some are big A, little a, but they're all going to be black sheep, okay? So the question for Hardy-Weinberg is trying to figure out, what are these proportions here of these two things? I'm going to highlight that. What's going on here? And that's really all it is. So we're going to call those proportions as we move to the next phase here, D, H, and R. And that stands for dominant, heterozygote, and recessive.